Welcome to the series of the blind 75. Today we are going to solve the next problem in this series, which is the maximum product subarray. Okay, so let's look at this problem. It says that given an integer array nums, find a subarray that has the largest product, return the product. Okay, and tests are generated so they will fit into 32-bit integer. So given this 2, 3 minus 2, 4. So 2 and 3, the product becomes 6, right? And it can also contain 0, right? So let's play around with this one use case. So to be able to find the maximum product of subarray, right? So let's say the subarray is ending at some index, right? So subarray could be ending at 0th index, subarray end could be ending with at first index, second index, third index, right? Now, if we could find the maximum product could be possible at any index, right? Then we should be able to determine what is the maximum product, right? So, how we will determine the maximum product at any index I, right? So to find the maximum product, so we need to know the maximum product at I minus 1, right? Okay, now to find the maximum product of the I minus 1, right? So this is a product as well, right? So in this, if we have the minimum, like if there is a negative and there is a negative as well, right? Let's say minus 2 or minus 4, then it will become the maximum and the minimum as well, right? We need to consider the minimum as well. So this is, let's say, the maximum product. And we would find the minimum product as well, right? Minimum product ending at index I, right? And to find this, so it would become basically the max of multiply by nums of I, right? This will become the maximum. And we need to find the minimum as well, right? So to find the minimum, because that will be required for the next step, this would be the minimum of these two and multiply by this, correct? So if we try this approach, right? So let's say this is the max, this is the min. So what we'll do for the first index, both will remain same. Now maximum of these two, multiply this becomes 6, right? And minimum will also be 2 and this will come again 6. Now in this case the maximum is 6 again and this will become the minus 2, right? Right, I think maximum also we need to consider the current element as well, right? So it will not be just the multiply by this, this would be the maximum of this as well, right? If we do not include at all the previous one, and similarly this would be the minimum of this one as well. Correct. So this becomes the minus 12, so we would consider the minus 2 only, and this would become the minus 12, right? And this would be the for the maximum here is the minus 2, minus 8, and this will be 4 only, and then minus here the minimum doesn't matter, right? So the maximum is 6 only. Okay, let's do one variation of it actually. Okay, so I'll take the same example and let me do this minus 4 actually. Okay, and let's see what happens. And so this will be 2 and 2, 3 and 2, this will be 6 and 6 only. Now in this case, minus maximum is 6 and minus 12, and then here it is the minus 2 only. Okay, and here it will be again minimum. We need to find the minimum, which is the minus 12. Okay, now over here it actually becomes the minus 4, so we will do the maximum of it, right? So minus 2, correct? Yeah, actually it doesn't has to be, this would be always be minimum, right? It can be in any case. So this equation needs to be rewritten, right? So what we are saying is that we will do all this combination basically, right? Minus 2 multiplied by minus 4, right? So one is that we have 8, right? We have minus 12 and minus 4, which is the 48, right? Another contender we have, we do not multiply at all, right? We keep the minus 4, right? And in this case the maximum is 48, right? And the minimum is minus 4, right? So a bit of correction we would need to do over here. So right, shall we take one more example to gain one bit more confidence? So let's say, let's do this minus 2 this time. Okay, and this will become the minus 2 again, right? Now this equation will become with change. Here we are saying that maximum of this, this, and this, right? And this will just become the minimum. Take the minimum of it, right? Now 3, it would be 3 only, because in the minimum would be the minus 6, correct? Now and minus 2 is we need to find the maximum, right? So one is that -6, 12, so here it is 12, and minimum would be the -6, I guess, right? Move the -6. Now the maximum would be the, here it would be the 24, I think the maximum, and I guess the minimum is the -48, right? And I think this is the maximum only, right? Okay, let's try this approach and see how many test cases are getting passed. So in so what we need to do is, so we have three products, right? So maximum product, so I'll take the max p, which is the nums of 0, and again min, which is also nums of 0, right? And I'll iterate I less than nums dot. Okay, this is start from 1. Now what I will do is that I'll take um, 3 variables, a, b and c, right? So to simplify, nums, it's the max p multiply by nums of I minus 1, right? And c is actually nums I, so I'll take a and b, and this is the min of p, right? And the max p will become the math dot max a comma b, and this will always be math max b nums I, right? This will be I, right? Not I minus 1. Okay, and this would be the minimum of these 3 numbers, right? And this will be the min. And I guess we need to return the maximum product, correct? Right, let's run this. Okay, it gives me the wrong answer. Here the answer is 4. Okay, I think I missed one major thing, which is the int max product so far, right? So let's say it's max p, and this will be the math dot max product so far. It's the max p, right? And I think this should be this one. Okay, let me try one more use case before submitting it. Okay, test case. So I'll take -4 and C. Okay, let me submit it. Okay, yeah. I think let's look at these solutions as well. If what I think the complexity that we have solved is the um, time complexity is big O of n, right? And yes, so the time complexity is big O of n, space is 1. Yeah. Okay. Thank you.